This is Sridhar Patnaik. Today we are going to learn another sum about the group. Let us see. This is very important sum. So many times this problem was asked in degree examination papers. This is very important sum. So friends, let us see once what is about this problem. Prove that the set of all matrices A alpha, cos alpha minus sin alpha, cos alpha belongs to R, form a group with respect to matrices multiplication if cos theta is equal to cos phi. Let us see the solution, friends. Given that, what is given? First of all, given that A alpha is equal to cos alpha minus sin alpha cos alpha, where alpha belongs to R. Alpha belongs to R. We have to prove that the set of all matrices of this form is a group under matrix multiplication. Matrices multiplication. Let G is equal to A alpha such that alpha belongs to R. Alpha belongs to R. I named the set of all matrices by the set G. Now I wanted to prove that G is a group under matrix multiplication. If we wanted to prove G is a group under matrix multiplication, we have to prove all the postulates, closure, associative, existence of identity, inverse under the matrix multiplication. First of all, I wanted to prove closure law. Let A alpha, A beta belongs to G, where alpha, beta belongs to R. Now, A alpha into A beta, I wanted to do this. What is this? Here dot indicates matrices multiplication. This is cos alpha minus sin alpha, or otherwise cos alpha minus sin alpha into cos alpha. This is into cos beta minus sin beta into cos alpha. Matrices multiplication. Like this. This is row, this is row, this is now cos alpha, this is now cos alpha, cos beta, this row with this column, minus sin alpha, sin beta. Next, this row with this column, cos alpha minus cos alpha, sin beta, minus sin alpha, cos beta. Sin alpha, cos beta. Now the second row with the first column, sin alpha, cos beta plus cos alpha, sin beta. Cos alpha, sin beta. Second one, minus sin alpha, sin beta plus cos alpha into cos beta. This is what is this? Cos alpha, cos beta minus sin alpha, sin beta. Cos alpha plus beta. This is the formula, you know. This is minus, I am taking as a factor common from this. This is sin alpha plus beta. Sin alpha plus beta. Here also same. Sin alpha plus beta. Sin alpha plus beta. This is also cos alpha, cos beta minus sin alpha, sin beta. This is cos alpha plus beta. I wanted to represent this with C alpha plus beta. C alpha plus beta. Friends, now whether C alpha plus beta belongs to G or not, let us check once. Beta belongs to R implies alpha plus beta also belongs to R. Therefore C alpha plus beta belongs to G. See, alpha plus beta belongs to G. Therefore, matrices multiplication is closer on G. Matrices multiplication is closer on G, and therefore matrices multiplication on G obeys closure law. Matrices multiplication obeys closure law on G. Closure law on G. Therefore, we satisfy the closure law. We satisfies the closure law. Associative law. Let A alpha, A beta, A gamma belongs to G, where alpha, beta, gamma belongs to R. We know that alpha plus beta plus gamma is equal to alpha plus beta gamma. For all alpha, beta, gamma belongs to R, because these are all real numbers. Addition of real numbers is associative. Addition of real numbers is associative. A alpha into A beta. I wanted to check this. This is we get A alpha plus beta. This is A alpha into A beta is equal to A alpha plus A beta into A gamma. A gamma. This becomes A alpha plus beta plus gamma. A alpha plus beta plus gamma. Similarly, this I wanted to write like A beta plus gamma. A beta plus gamma. This is A alpha into A beta plus gamma. A beta plus gamma. This becomes A alpha into A beta into A gamma. A gamma. Therefore, matrices multiplication is associative on G. Matrices multiplication is associative on G. This is therefore A alpha into A beta into A gamma is equal to A alpha into A beta into A gamma for all alpha beta belongs to R. Therefore, matrix multiplication is associative on G. Therefore, G is semi-group under matrix multiplication. Friends, now existence of identity. We know that 1001 is equal cos 0 minus sin 0 cos 0. Friends, we can write like this: the matrix 1001 as cos 0 is equal to 1, sin 0 is 0, whether it is positive or negative there is no difference. Sin 0, cos 0 is 1. Now I wanted to write this matrix as A0 where 0 belongs to R. Now A alpha into A0. We know that alpha plus 0 is equal to 0 plus alpha is equal to alpha for all alpha belongs to R. Now A alpha into A0. What is this? A alpha plus 0. This is A alpha. Similarly, A0 into A alpha. This is A0 plus A alpha. This is A alpha. Friends, so A alpha into A0 is equal A0 into A alpha is equal to A alpha for all alpha belongs to R. So that A0 is the identity element in G. Therefore matrix multiplication. Therefore matrix multiplication obeys the identity law in G. Therefore G is a monoid. Therefore friends, G is a monoid. We have seen identity element because identity element is existed, that is A0. With this property, with this postulate, we can say G is monoid. Existence of inverse. So let alpha belongs to R implies minus alpha belongs to R. We know that alpha plus minus alpha is equal to minus alpha plus alpha is equal to 0 for all alpha belongs to R. Now let A alpha belongs to G. Now this implies A minus alpha also belongs to G. A of minus alpha also belongs to G. What is A alpha into A minus alpha? This is A alpha plus minus alpha. This is A0. Similarly, A minus alpha into A alpha is equal to A minus alpha plus alpha. This is A0. Therefore, A alpha into A minus alpha is equal to A minus alpha into A alpha is equal to A0. Therefore, A minus alpha is the inverse element of A minus alpha is the inverse element of A alpha in G with respect to matrix multiplication. Therefore, matrix multiplication obeys the inverse law on G. Therefore, G is a group with respect to matrix multiplication. Therefore, G is a group with respect to matrix multiplication. Friends, this is the problem. The G is a group under matrix multiplication. Next, I wanted to law. Suppose that beta belongs to R. We know that alpha plus beta is equal to beta plus alpha for all alpha comma beta belongs to R. Let A alpha, A beta belongs to G. Now A alpha into A beta, this becomes A alpha plus beta. Now in place of alpha plus beta, I wanted to write A beta plus alpha. This can be written as A beta into A alpha. Therefore, A alpha, A beta is equal to A beta, A alpha for all For all A alpha comma A beta belongs to G. Therefore, G is G. Therefore, matrix multiplication. Matrix multiplication obeys commutative law. Commutative law on G. Therefore, G is abelian group. G is abelian group under matrix multiplication. Okay, friends, this is the one of the very most important problem. Friends, if you like my class, if you like my teaching, please see my YouTube channel. Also, please I request to subscribe my channel.